Section 25 is the cross product of two vectors in space. That means in 3 dimensions. First thing we should talk about is this circle. This circle will make your life a little bit easier. We have I. Well, let me not put it there. We have J and we have K. Going in the clockwise direction, we have the fact. Notice first I, then J, then K. We have I cross J equals K. If you want to start with J first, go in the clockwise direction. We have J, and then K, and then I. J, K, and I. J cross K is I. Starting with K, the next one is I, going clockwise. And then J. K cross I is J. Now, if we go in the opposite direction, the same thing happens, except the final answer will be negative, whatever you get. What on earth do I mean? If you write I, K, J. I, and then K, and then J. Since I went in the counterclockwise direction, I cross K does not equal J, it equals negative J. If you start with K and you go counterclockwise, you get J, and you continue counterclockwise, you get I. K cross J does not equal I, but rather negative I. If you start with J, then you go to I, and then you get to K. J cross I is not K, but negative K. You have a circle, and in the clockwise position, you go in alphabetical order. I, J, K. I cross J is K. K cross J is I. K cross I is J. It just keeps going around in circles. If you want to do I cross K, you have to go this way, counterclockwise. So you're going to get J, negative J. If you want to do J cross I, you have to go counterclockwise. J cross I is not K, but negative K. Know this circle. Clockwise, I, J, K. So we have, so let U equal 12, negative 3, 0. And let V equal negative 2, 5, 0. It turns out that if you take the cross product of U and V, it would be orthogonal to both U and V, it being U cross V. The cross product will be orthogonal to U, and the cross product will be orthogonal to V. The cross product is a vector, and if U, which is a vector, and U cross V is a vector, if they're orthogonal, then their dot product will be 0. U cross V is a vector, and V is a vector. If you dot these two vectors and they're orthogonal, you get 0. And I want to find U cross V, and I want to show that that new vector is orthogonal to the original 2. So U cross V, you get I, J, K, then you write down vector U, and then you write down vector V. The easiest way of doing this finding this determinant. So we want to find this determinant. The easiest way of doing it is to write it down again and use what's called the spaghetti method. Repeat the first column at the end, and then repeat the second column at the end. And then it'll be one mess minus another mess. It'll be this product, which is 0, plus this product, which is 0, plus this product, which is 60k. That's all that survived in the first bracket because the other two terms were 0, minus, now we go in the other direction on the diagonal. Here when we multiply those 3 entries, we get 6k. When we multiply those 2 entries, since there's a 0, we get 0. The next 3, we get 0. And that's it. Only do the diagonals that have 3. That is, do not bother to look at this diagonal. It only has 2 values. This one only had 1. This only has 2 and 1. Only do the ones that have 3. So this is all that we got. And 60k minus 6k is 54k. That means 0 i's, 0 j's, and 54k. And I claim that this new vector, I claim that their vector u cross v, 54k, is orthogonal to u and v. Maybe I'm making this up. Let's see if I'm right. You're definitely going to be asked to verify this. So, u dot u cross v. Well, u is right above. It's 12, negative 3, 0. And I want to dot this. This is a vector. I really should be using the vector bracket. Sorry. Dotted with u cross v, which is 0, 0, 54. Dot product. You multiply the first entry, you get 0, plus. You multiply the second entry, you get 0, plus. Multiply the third entry, you get 0. We got 0. They are orthogonal. They being u and u cross v. What about v? Is v really orthogonal to u cross v? The answer is, you better believe it. Given 2 vectors, if you can find the cross product, that cross product will be orthogonal to the original 2 vectors. Okay, v cross u cross v. Well, v is above, it's negative 2, 5, 0. And u cross v is 0, 0, 54. Multiply the first entries, you get 0, plus. Multiply the second entry, 0, plus. Multiply the third entry, 0. Bingo, you get 0. Okay. Remember, when you cross vectors x and y, the cosine of theta is x dotted with y divided by the length of x times the length of y. Well, if x dot y is 0, you get 0 on top. And the lengths of x and y, both of them are non-zero. So their product will not be 0. 0 divided by not 0 is 0. And if the cosine of an angle is 0, then the angle is 90 degrees. That means the vectors are orthogonal. They meet at right angles. They're perpendicular. So if you cross 2 vectors, 3-dimensional vectors, vectors in space, and you get a new vector after you cross them, the new vector will be perpendicular or orthogonal to each of the vectors. So now, suppose that you want to find the area of a parallelogram where you're giving two adjacent sides. For example, you have vector u and you have vector v. Those are two adjacent sides. The other two sides will be these two sides. And you get a parallelogram. Their instructions ask to find the area of this parallelogram. It's easy to prove the theorem, but let's not do that. The area is the length of u cross v, which happens to be the length of u times the length of v times the sine of the angle between u and v. And we're given u. We're told that u is 0, 1, 0, and v happens to be 0, 1, 1. We're given vector u, and we are given not the point, but rather the vector u. We have u and v. And we can find the length of u, we can find the length of v. Cosine of the angle might be a pain. But it's easier to use this formula. Sometimes you'll use that formula. If they tell you the length, they tell you the angle. If they tell you the angle, I'd rather find the length of u and the length of v and multiply it by the sine of the angle that's given rather than doing a cross product. So we don't have our choice here. Not only do we have to find a cross product, but then we have to find the length of it. So if you're given the angle, it's easier to use the second one. That's why I bothered to write it down. U cross v. I, j, k. Then you write down u. Then you write down v. Yes, the order matters. But not if you're really finding the length. Because if you do it backwards, you'll find if u cross v was -3, 1, 2, and you did it backwards, you'll get plus, that is, you interchange these. You get +3, -1, -2. Those are the same lengths. One vector goes one way, and the other vector goes in the opposite direction, the same length. So since we want the length, it doesn't matter. That is, the length of u cross v is the same as the length of v cross u. But let us find out this determinant. Let's find out this determinant. So we repeat the first two columns. I, 0, 0, j, 1, 1. We multiply these, we get 0. We multiply these, we multiply these and we get 1i. We multiply the next one, we get 0. The next one is 0. We multiply the three entries. 0 times 1 times k is 0. So I did their diagonals in one direction, now I'm doing it in the other direction. And I just got 0k. 1 times 0 times I is 0. 1 times 0 times I, 0. Awful lot of zeros. So we just got 1i. So we have u cross v, 1i, we want the length of it. It's just 1. Remember, 1i is 1i, 0j, 0k. So you square the 1, you square the 0, you square the 1, you add them up, you get 1. That doesn't mean that's the answer. You take the square root of that, which is also 1. So the length, the area is 1. The area is 1. I want to see something myself, please. Okay, the area is 1. So now you have another way of finding the area of a parallelogram. In other words, if you are ever given the following, this in 2 dimensions, this is 1, 3, that just means z is 0. And you're given 2, 4. Well, problem is it has to be parallel, which is going to be brutal. Let's see. If I give you 0, 4, and I give you 1, 5. Now I ask you, what is the area of this parallelogram? Well, what you can do is find this vector and find this vector and do the cross product. The first vector is 2 minus 1 is 1. 4 minus 3 is also 1. It's that. And this vector here, well, it's 0 minus 1, which is minus 1. And 4 minus 3 is 1. I'm just doing head minus tail. And we can find the area. Now, okay. I wonder if we can really, we're going to have problems. So, to just think of x, y, or, think of 2, 4 as 2, 4, 0. Let all the z values just be 0. Think of all the z values as 0. It's right on their xy plane. It's not one above or one below. So we have I, j, k. The first vector is 1, 1, 0. The second vector is negative 1, 1, 0. Repeat the first 2 columns. Spaghetti. So the area is equal to this product, which is 0, because it is 0, plus this product, which is 0, because it is 0, plus this product, which is 1k, minus that product is negative k, negative 1k. This product is 0 because this is 0, and this product is 0 because that's a 0. So that's it. Don't say that's 0, because if you do, it's because you know that 1k minus 1k is 0. But that's not 1k. It's negative 1k. It's not 1k. So what we get is 2k. Now, actually, the area is the magnitude of the cross product. We just found the cross product. The cross product is at 0 i's, 0 j's, and 2k. And we want the length of this, which is 0 squared plus 0 squared plus 2 squared, square root of that, which is 2. The area is 2. You didn't have to find the angle. You didn't have to find the height. Ordinarily, back in our elementary algebra, you would find the length of this. You would do 4 minus 3, which for the record I did, and you would square it. Then you would do 2 minus 1, which I also did, and you would square it, which is 1. And you'd add them up, and you get the square root of 2. This length is the square root of 2. And then, at a right angle to the base, you'd have to find this height. You'd have to find that height. Have fun finding that height. That is why it's not off the wall to find the area of a parallelogram using cross products. Just let z equal 0. In fact, if you don't like 0, you can let z equal 311. Or pi squared over 4. It won't matter because if the z's are the same for all 4 points, doesn't matter what it is. Now, suppose they ask you to find the area of a parallelogram, but they only give you the points. They only give you the points. 1, 1, 1, 2, 3, 4, 6, 5, 2, 7, 7, 5. Now, the biggest problem is that, and you don't want to graph this, okay? You lose your mind graphing this. The thing is, so let's give these names so we can talk about them without having to read off the points each time. Now, if P1 is here and P2 is half, well then, we don't really want to find a vector that goes from P1 to P2. We want to find a vector that goes from here to here. We want to find out what that vector is. We want to find out what this vector is. We want to see if they're parallel. And then we want to find out these two vectors to see if they're parallel. So that creates a problem because we don't know the ordering. We don't know the ordering. But let's find P1, P2. I didn't mean to put the arrow there. P1, P2. P1 to P2. So the head is P2. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. That's P1, P2. Let's call that P1, that P2. Okay. Now we're really proceeding as if we're blind. We have absolutely no idea what's going on. Let us suppose P3 is here and P4 is here. Let us find P1, P4. Now, it might be that this is P1 and that's P4. Well, okay, this might be P3. So we really should be finding P1, P3, which we're not. And I might have said it correctly, but I wrote it wrong. We just found P1, P2. Now I want to see if P3, P4 is parallel to it. So P3 to P4. 7 minus 3, 7 minus 6 is 1, 7 minus 5 is 2, and 5 minus 2 is 3. Fortunately, they're parallel. In fact, they're the same vector. Not only are they parallel, but they're the same length. That is, when you shift them over to the origin, when you find the component form, they're the same component. That is, if the origin happened to be here, P1, P2 would come here, and P3, P4 would be right on top of it. They're parallel and the same length. Well, is that enough? If you have two lines that are parallel and the same length, they're the same length, and then you connect the two dots like follows, would those be the same length and parallel? The answer is yes. The answer is yes. if you have a four-sided figure and two sides are parallel, the other sides don't need to be parallel. But if you have two opposite sides parallel and that are same length, forget about it. You don't have to worry anymore. The parallelogram. The parallelogram. Okay, so P1, P2 is parallel to P3, P4, and we'll call this the length of P1, P2 is equal to the length of P3, P4. That implies parallelogram. So it's definitely a parallelogram. Now, if you calculated P1, P2 and P3, P4, and they were not the same, then you look to see if one's a multiple of the other. Remember, the two adjacent sides can't be parallel. This side and this side can't be parallel, because then they'd just be one straight line when you link them together. I mean, this vector and this vector are linked together. They're linked right there at the corner. But if the second vector didn't go in the direction I'm erasing, but went in the exact same direction as the first vector, how are you getting a parallelogram? But if P3, P4 was a multiple of P1, P2, that is, if this would have been 2, 4, 6, then P1 and P2 are parallel. You have one side and you have another side. But the second side is 2 times as big. The second side is 2 times as big. And after all, you double these numbers, you get 2, 4, 6. It won't be a parallelogram. Now, having said that, if P3, P4 was not P1, P2, and it wasn't a multiple of P1, P2, then you shouldn't be trying P1, P2. Okay, I mean P3, P4. Possibly that's where it's going sour. Possibly, let me draw that better. Possibly P1 and P2 was not like that. P1 and P2 were not like that. Well, if they're not like that, what were they like? Well, if you put the P2 in the bottom right, well, that's exactly what we just had a moment when I put the P2 up here. Okay, so what happened was you had P2 there. So then what do? You have P3 and P4. Find that length, that vector, find that vector. If those are not parallel, then it's not a, and it failed the first time, then you don't have a parallelogram. You do not have a parallelogram. So usually they'll put it clockwise or counterclockwise. Usually, if they don't want to be rude or a pain. P1, P2, P3, P4. They probably would not call this P3 and that P2. That would be a pain to do that. That would be very unfriendly. It's just wasting your time. Or, maybe on an exam, your teacher wants to see if you know how to handle yourself when you get into trouble. And number 23, we'll just talk about this one. Remember that a triangle is half of a parallelogram. What on earth does that mean? Well, if at this point I draw something parallel to this, namely this, and at this point I draw something parallel to this, namely that, is a parallelogram. And this area is the same as that area. So the area of this would be 1/2 u cross the length of u cross v. And if they give you the 3 points, if they tell you this is 1, 1, 1 and 3, 2, 1 and 1, 0, 4, you can find this vector. Say it goes in that direction. You do 1 minus 1, you get 0. You do 0 minus 1, you get -1. You do 4 minus 1, you get 3. There's that vector. Actually, you don't want to do that one. I'm so sorry. Because that's not a vector in the parallelogram if you completed it. The reason I picked that one was because I wrote this in my way. I had this in my way. What you want to do is find this vector here. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. That's the component vector. And now you want to find this vector here. Say it goes in that direction. 1 minus 3 is -2. The 0 minus the 2 is -2. And the 4 minus the 1 is 3. So you have that component. So now you can compute u cross v. If we call that u and that v, find the lengths of that, and then scale it by 1/2. Because we're only finding half of it. We're finding this half. That's exactly why the area of a triangle is half base times height, or half length times width. If you completed the whole rectangle or parallelogram, it would be base times height. Now, we want to compute u dot v cross w. Of course, I need to give you u, v, and w. If u is I, v is j, and w is k. So v cross w would really be j cross k. Oh, that's the circle. I, j, k. Clockwise does not give you the negative sign. Counterclockwise gives you the negative sign. J cross k, and when clockwise, that gives me I. Okay, this is I. But I want u dotted with w, v cross w. So I get u, which is I, dotted with v cross w, which is I. I get I dotted with I. I is 1I, 0 j's, 0 k's. Dotted with 1I, 0 j's, 0 k's. Multiply the first components, get 1. Add on 0 times 0, which is 0. Add on 0 times 0, which is 0. Answer is 1. This is 1. Let's do one that's a little bit more interesting. Excuse me. Suppose you had u is equal to 2, 0, 1. And v is equal to 0, 3, 0. And w is equal to 0, 0, 1. And we want to compute U dot V cross W. Now before, I think we had I cross J. To direct it, I is 1, 0, 0. And J is 0, 1, 0. And I could have found I cross J by finding this determinant. That is, doing the spaghetti method. 1, 0, 0, 0, 1, 0, I 1, 0, J 0, 1, 0, 0, K minus 0, 0, 0. So we just got K, which is exactly what we got using a circle. But of course what I just did was a lot harder. Not harder, but a lot longer. Here it's harder. The circle is trivial. Okay. So we need to do U dotted with V cross W. So let's find V cross W. I, J, K, V is 0, 3, 0. W is 0, 0, 1. We repeat the first column and then the second column. We get 3i plus 0 j's plus 0 k's. I want to write that down. Minus 0 k's plus 0 i's plus 0 j's. It's just 3i. So I have 3 i's, 0 j's, 0 k's. And I dot those two vectors. I multiply the first values, I get 0, and I add on the product of the second entries, which is 0, which I won't even bother adding on. 0 times 0 is 0. Then I add on the product of the third numbers. 1 times 0 is 0. You add some zeros to 6, you still get 6. And that's your answer. So that's the way I've been showing you. The easiest way to find the determinant of 3 by 3. 3 rows, 3 columns. And that actually completes the section on the cross product of two vectors in space. Good luck with it.